Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with soil mechanics in the topic of pressure. So the problem is a retaining wall 10 meter height retains a cohesionless soil. So C equal to 0. So the cohesionless soil having an angle of internal friction, the phi equal to 30 degree. The surface of the soil is level with the top of the wall. So the top 33 meter fill has the unit weight of 20 kilonewton per meter cube and the top rest is 30 kilonewton per meter square. Okay, so this is gamma 1 value and this one is gamma 2 value. So find the magnitude per meter run and the point of application of the resultant active thrust. Okay, so now there is a two layer. So there is a retaining wall. So retaining wall has a two layers. First layer have 3 meters. So another layer has 7 meters. Okay, so total is 10 meter retaining wall. So now here the gamma value. So gamma value is 20 kilonewton per meter cube. So here the gamma value is 30 kilonewton per meter cube. Okay, so there is two layers over here. So then here also the both cases phi equal to 30 degree. Here also phi equal to 30 degree. Okay, so now we can draw the diagram. So earth pressure diagram. So the layer cut here. Okay, so this is the earth pressure diagram. So here the acting on P1, here is pressure P2, here pressure P3. Okay, so now we having the base dimension of Ka into gamma 1 into H1. Okay, so here also the same distance. So Ka into gamma 1 into H1. So here Ka into gamma 2 into H2. So here is the H2 distance. Here is the H1 distance. Okay, so now we can calculate the total magnitude, that is P1 plus P2 plus P3. Okay, so now, so first thing is we have to find out the Ka value. So Ka formula we know 1 minus sin phi divided by 1 plus sin phi. So now we can substitute the phi values over here. So 1 minus sin 30 degree divided by 1 plus sin 30 degree. Okay, solving this we got the value of 1 divided by 3. Okay, so next thing is we have to find out the P1 value. So P1, so the area of triangle, so half into B into H. So half into B value is Ka into gamma 1 into H1 into half B into H. So H1. Okay, so now we can substitute all the values over here. So now half into Ka value is 1 by 3 into gamma 1 value is 20 into H1 value is 3 meter into 3 meter. So solving this we got the value of 30 kilonewton per meter. Okay, so next thing is P2 value. So P2 is rectangle. So now B into H, so that is Ka into gamma 1 into H1 into H1, sorry H2. Okay, so the base into height. So now we can substitute the Ka value is 1 by 3 into gamma 1 value is 20 into H1 value is 3 into H2 value is 7. Okay, so solving this we got the value of 140 kilonewton per meter. Okay, so next thing is P3. So P3 values of BH. So half into B value is Ka into gamma 2 into H2 into the H value is H2. Okay, so now we can substitute 1 by 2 into Ka value is 1 by 3 into gamma 2 value is 30 into H2 value is 7 meter into 7. Okay, so solving this we got the value of 245 kilonewton per meter. Okay, so now we can add all those things. So the P equal to P1 plus P2 plus P3. So now 30 plus 140 plus 245. Okay, so total 415 kilonewton per meter. Okay, so this is the total magnitude per meter run. Okay, so next thing is we have to find out the point of application. So the point of application, for that point of application we have to find out the Z values. So for that this triangle, so for point of application we can calculate from here. So for now Z1 equal to, so Z1 equal to, the total distance is 7 meter plus, so here is 1 by 3, 1 by third of, so the height is 3 meter. Okay, so now we got the 8 meter. Okay, so second thing is Z2. Z2 here we have to find out the total distance divided by 2. So 7 by 2 is 3.5 meter. So Z3, so we having the distance by 3, so that is 7 by 3. Okay, distance into 1 by 3, so 7 by 3, we having the point of application of 2.33 meter. Okay, so these are all the distance, the points acting here. So now we can find out the point of application. So now Z equal to P1 plus, so P1 plus 8. Okay, so that's why we are putting 30 into 8 again plus P2 into Z2, that is P2 is 140 into 3.5. Okay, plus P3 is 245 into Z3 value is 2.33. Okay, so divided by 30 plus 140 plus 245. Okay, so that is 415. So totally we have solving this, we got the answer of 3.137 meter. Okay, so this is the point of application of total pressure. So now here the total pressure in the from the base is, so here is 3.137 total P, that is 415 is acting over here. Okay, so this is the method we can solve the problem. Again we will see next video. Thank you.